Bismillahirrahmanirrahim. This is a video about an exercise that I treated last time, and I was wrong on some details. So I apologize first, and then I will give you a new approach, which is true, inshallah. Donc the first question, the exercise, let f and g be two continuous functions on 0, 1. Let phi be the function defined by phi of t equal to the supplement of f of x plus t g of x on x between 0 and 1. The first question is show that phi is well defined on R. Solution, first question, let t be a real number, let t be a real number, and consider the function theta from 0, 1 into R such that x, we associate f of x plus t g of x. Theta is a continuous function as a combination of two functions, and here we have a product, a scalar product. T is a real number, so this function is continuous on a bounded and closed interval. So theta attains its bounds. This is Hein theorem. Then there exists x index t from 0, 1, such that what? Such that the supplement of theta of x between 1 and 0, this is equal to theta x index t. Then phi of t is actually equal to the supplement of phi theta of x. Then one has phi of t, which is equal to theta xt, which is well defined on R. This is the first question. The second question, I think that I need all the places, so I will clear this. This is the first question. The second question, show that phi is well defined. We set from the previous question that phi of t is equal to theta of xt, which is equal to f of x index t plus t g x index t. Let us t and t prime, let t and t prime two real numbers, and let us consider phi of t minus phi of t prime. This is equal by definition, this is equal to f of xt plus t g of x index t minus f of x t prime minus t prime g of x t prime, which is equal to f xt plus t g x t minus f of x t prime minus t prime g of x t prime. The same formula. Here, this t, I will write it like this. So this t here, I will write it like this. We have here, once again, we have f of xt plus this t, I mean this t, is equal to t minus t prime plus t prime g of x t. From what we have f of x t plus I will take this here plus t minus t prime g of x t here plus here t prime g of x t plus t prime g of x t prime minus f of x t prime minus t prime g of x t prime. This is the same thing, and we write it equal to f of x t plus t prime g of x t. Just here I need to clarify this like this, t prime minus f of x t prime minus plus t prime g of x t prime plus t minus t prime g of x t. I need once again t prime here, t prime, and t prime here, and t prime here. From this formula, we deduce that xt prime is the maximum. In this case. Here we have xt, and here we have t prime. Here we have xt prime, t prime, g of xt prime. So xt prime is the maximum in this case. So our function phi of t attains the maximum at the point xt prime from this formula. So this is negative. If it is negative, this will be less than or equal t minus t prime, the last one in blue color, g of xt. This is 1. This is 1. I mean for all t and t prime from R, one has phi of t minus phi of t prime is less than or equal this. I think that I can use this part of the whiteboard. We have for t and t prime, for all t and t prime from any given, from R, we have what? We have phi of t minus phi of t prime. This is less than or equal to t minus t prime g of x t g of x. This is first. Second, this is 1a, b, for t and t prime from R. Let us consider phi of t prime minus phi of t. This is, we will repeat the same thing. We will repeat the this change, so this replacement. At the last, it will be less for the same reason. Here we will get f of x t prime, f of x t prime, t g of x t prime, and here we will get f of xt plus t g of xt. This means that the maximum is attained here, and since it is attained here, it will be negative, and this will be less than or equal to t prime minus t g of x t prime. Trust me, if we replace here, we replace t by, we replace t prime by t prime minus t plus t, the same, symmetry, we will get this. And for the same reason, we will get that it is less than or equal, since this is negative. In this case, what we can write, we can remark that from here, phi of t minus phi of t prime, this one, is greater than or equal t minus t prime g of x t prime. We just times by minus 0, or we take them in the other sides. At the least, one has phi of t minus phi of t prime. From the side, it is less than t prime minus t g of x t here, yeah, t prime here. Okay, this the first one. The first one we have t minus t prime g of xt from this one, and it is greater than or equal to this one, which is t minus t prime g of xt prime, which implies that the absolute value of phi of t prime is less than or equal the maximum between this one and this one. I mean t minus t prime g of xt and t minus t prime g of xt prime. Yes, this, which is less than or equal t minus t prime, and here we have the supremum of g of the supremum, and the supremum g of xt and g of xt prime cannot attain. It can attain, but they are less than the maximum of g of x on 0, 1. If we take the m equal to the supremum of g of x, x between 1 and 0, we can put it here. Finally, there exists m, which is positive and is the absolute value, the maximum of this function, such that for all t and t prime from R, one has phi of t minus phi of t prime. This is less than or equal to m t minus t prime. This means that it is Lipschitzian. Thank you very much. It was not easy. See you next time.